Good morning to all. So let's going to discuss PN junction diode. So before going to topic, let's have a small introduction regarding this electronics field: insulators, semiconductors, and conductors. What is insulators? It is a poor conduction of the material, and the forbidden band is very large, and it is having a number of free electrons is less. So most of the time they prefer the semiconductors. So what is semiconductor? It is a partially conducting material when more conduction and compare with the insulators. So when semiconductor material is having a room temperature, or it is external field is applied, so more current is flowing in the material. That's why people prefer the semiconductors. What about the conductors? So the conductors is having large conduction and compared with the semiconductors, that is the conduction band is very more. When you compare with these three in the electronics field, people go with the semiconductors. So semiconductors are classified into intrinsic semiconductors and the extrinsic semiconductors. What is intrinsic semiconductors? So the number of charge carriers is therefore determined by the properties of material itself instead of amount of impurities. That is, it is a pure semiconducting material. And what about the extrinsic semiconducting material? It is a impure semiconducting material. So for this topic we need a extrinsic semiconducting material. So this extrinsic semiconducting material is classified into n-type material and p-type material. Let's move on to the n-type and p-type material. First one, n-type semiconductor. What is n-type semiconductor? So a small amount of pentavalent impurity is added to the pure semiconductor. It is known as n-type semiconductor. For example, antimony, phosphorus, and etc. So if you look into this diagram, it's having arsenic and germanium. So arsenic is having 5 valence electrons and germanium is having 4 valence electrons. One free electrons is left. It will move from valence band to the conduction band, and it is a donor impurity. And when you refer the diagram, it is having a one free electron. It will move from valence band to the conduction band. What about the p-type semiconductor material? So a small amount of trivalent impurities added to the pure semiconductor is called the p-type material. Example, boron, gallium, and a lot of materials are there. So in this, germanium is having 4 valence value, and gallium is having a 3 valence value. And if you take this, one incomplete hole is available here. If you refer the diagram, one incomplete hole, and it is nothing but acceptor impurity. When you compare with the n-type, it is acceptor impurity, whereas n-type is a donor impurity. These two things are very important one. So once if you framed this n-type and p-type, designed the n-type and p-type material, semiconducting material, let us move on to the diode. So what is diode? So highly concentrated n-type material and p-type material are combined, we will get a two-terminal semiconducting material called the diode. So diode is having p-type material and one-type material. In other words, we can call it as one anode and the cathode. Once if you combined the p-type material and n-type material, there is a very important process is undergone in the diode. So what is that important process means? The n-type material is diffused into the p-type material. The n-type electrons is attracted towards to the p-type material. It will move to the material, whereas p-type material is holes are crossed the and enter into the n-type material. And if you meeting point of p-type and n-type material is nothing but junction, that's why it is called p-n junction. Okay, next one, if you combination takes place, what happen means the movement of electrons and holes from one place to other place, it will attract over to the p-type material and it will attract to the n-type material. and after one stage there is no movement takes place. So there is a negative potential is developed, that is a positive ion is depleted in the n type region in the junction, and negative ions are depleted in the p-type material. So a negative built-in potential is developed in the region. That region is called the depletion region. That layer is called the depletion layer. So what is the value of this negative barrier potential means, if you refer the diagram, there is a built-in potential. So that is a diagram of a built-in potential. What is the value means, if you use a silicon material, the built-in potential is 0.6. If you use a germanium, the built-in potential is 0.3. So this concept is very important when you go with the PN junction diode. So refer this diagram. Once if you built-in potential is developed, we can go for the analysis, that is characteristics of your PN junction diode. So how to analyze the characteristics? By means of applying a external potential. So by means of applying external potential is called the biasing. So biasing means we are giving an external power supply to the PN junction diode. Simultaneously we are analyzing the characteristics of your PN junction diode. This biasing is classified into forward biasing and the reverse biasing. So let us move on to the forward biasing. What is a forward biasing? So forward biasing is nothing but, if you take the PN junction diode and connect the positive p-type material to the positive end of the battery, and take the n-type material connected to the negative end of the battery. So this process is nothing but forward biasing. So if you increase the voltage, note down the corresponding output value. Let us go to the characteristics of your another diagram shows the characteristics of your forward biasing PN junction diode. If you increase the value forward voltage, for example I am increasing 0.1 volt. So keep in mind, already we have a built-in potential, negative barrier is developed in the junction, so that is a minus 0.6. If you give the 0.1 volt as a forward voltage, what happen means the built-in potential distract the my input voltage, forward voltage, and it won't allow the value to the next region. So there is a zero amount of current is flowing in the diode. So if you note down the value, input voltage is a 0.1 volt, current is 0. Next, when you keep on increasing 0.2, 0.3, so up to some value the output current is 0. So when the diode is conducting means when the depletion layer is disappear. When the depletion layer is disappear means when you increase the forward voltage greater than the 0.6. Here I am using a silicon material. So when the forward voltage is greater than the depletion layer, automatically my depletion region is disappear or it is eliminated. A small amount of milliamps current is entering into the material. So what happened? A small amount of material is current is entering into the material. So current is flowing. So if you note down 0.6, a small amount of current. So shall we increase the input voltage? Yeah, you can increase. But what is your output current means? If you increase very small voltage, for example, already I reached the 0.6 volt, and if you increase a 0.01 voltage, that is 0.61 volt, my current value is rapidly increasing. So what is the relationship between your input voltage and the output current means? I is directly proportional to e power v, so exponential power v. So if you increase the voltage after reaching the depletion region eliminated, if you increase the voltage, automatically current value rapidly increasing. That is, my input voltage almost constant and the current value is increasing, my diode is conducting. So it is under the forward biasing condition. What about reverse bias? It is a VA characteristics. So my VF is greater than the V naught. The potential barrier at the junction completely disappear, and hence the holes cross the junction from P to N type material, and electrons cross the junction to opposite direction, resulting large current flow in the external circuit. So whenever the forward biasing, the current is flowing from higher potential to lower potential, and the electrons is flowing in the opposite direction, and you will get the maximum number of current. Now let us move on to the reverse biasing. So what is a reverse biasing? So when you go for the reverse biasing, so the p-type material is connected to the negative terminal of the battery. The figure shows the p-type material is connected to the negative terminal of the battery, and n-type material is connected to the positive terminal of the battery. And if you increase the voltage, let us move on to the characteristics. What happened when you increase the forward voltage in the negative direction, for example minus 0.1? So already we have a depletion region is having junction potential, built-in potential value is minus 0.6. So if you increase the negative voltage, what happened? The width of the depletion region is increasing. So if you increase the width of the depletion region, there is a zero amount of current, there is no flow of current in the device. So if you keep on increasing the forward voltage, my width of the depletion region is increasing, but there is a due to the minority carriers, there is a small amount of current is flowing in the circuit into 10 power minus 6. Okay sir, when you keep on increasing, at one stage what happened, my reverse voltage becomes constant or it is breakdown, and the current value is rapidly increasing in the reverse stage. So if you increase the value, the device get heated and more number of current is flowing, reverse saturation current is flowing in the device, and device get damaged. So this is a reverse biasing. So theoretically speaking, no current flow in the external circuit, but in practice very small amount of current of the order of few microamps flows under the reverse bias condition. So this is the overall characteristics of your VA characteristics of your PN junction diode. So in the important concept is knee voltage. In the forward biasing, note down the knee voltage, KNEE voltage. What is a knee voltage means? So if you increase the forward voltage in one direction and it reaches the knee voltage, means after that my voltage becomes constant and the current value rapidly increasing. That point is nothing but your knee voltage. So for the knee voltage, for the given PN junction diode, knee voltage is almost 0.6 to 0.7 for the given silicon semiconducting material. If you go for germanium, it is a different one. So the knee voltage is a different, it's an important one when you go with the PN junction diode. So in the data sheet, you have to refer this knee voltage. So coming to the reverse bias condition, if you look into this, at one stage the device get breakdown and you will have a rapidly increasing current, and at one stage it will get damaged. So this is a VI characteristics of your given PN junction diode. Next, another important concept, if you have to aware this one, breakdown. So what is a breakdown means? If you increase the reverse voltage in one direction, PN junction reverse voltage in one direction, the device get breakdown and the current value is increasing. So that value is nothing but avalanche breakdown. That is, it is PN junction is having a very thick junction. So avalanche breakdown is a high reverse voltage across the diode. So if your applied voltage is increasing, the electric field across the junction is increasing. The force is exerts on the electrons at junction and it frees them from covalent bonds. These free electrons gained the acceleration and it starts moving across the junction with a very high velocity. This results in collision with nearby atoms, and this collision generated further free electrons. So the electron hole pair recombination occurs across the junction. This free electrons creates the electron hole recombination, and more number of reverse saturation current is generated. The device get heated and at one stage the device get damaged or burst down. So this is a avalanche breakdown. So always operate the diode under the forward bias condition. That's why it is called the two terminal unidirectional semiconducting device. So always my device PN junction is allowing only in the forward direction, not in the reverse direction. So some of the applications of a PN junction diode are, it is mainly referred in several applications like switching operations, and mainly it is used in rectifiers. What is a rectifier? Analog to AC signal to DC signal. So if you go with a half-wave rectifier, So if you apply input voltage, automatically during a positive cycle it will give some value. During the reverse cycle it won't give some value. So it is halfway rectifier. With the help of diode only we can rectify the AC to DC signal.